All right, guys, so today we're going to be talking about USBs, also known as Universal Serial Buses. And USBs are basically the de facto standard in which we plug in external devices into our computer, right? So whether it be a mouse, a keyboard, a scanner, a printer, a monitor, whatever it is, we're going to use a USB slot to plug it in. And most people use these USB connectors, and they don't really know what they're looking at when they use it. They just know that they could plug in their device and have it work through the USB. And I'm going to go over some of the things you guys should know about the USB and some of the connectors also. So before we get into some of the details on USBs, I just want to cover a quick concept that you guys should be aware of. Okay, so when you plug in a device using a USB into your computer, it's not like the device is giving commands to the computer, right? It's actually the other way around. The computer is telling the device what to do. Now, the information that flows through, or the zeros and ones, or the data that goes through the external device or the peripheral device, whatever you want to call it, right? It goes from side A to side B. So let's say the computer had a mouse in this scenario, right? The information would go from side A down to the mouse to side B, right? So the side A that plugs into the computer, that would be called a USB A. And then the side that goes back into the peripheral device, that would be called a USB B. The most common USB connectors are these right here. Pretty much every device that you're going to see, every peripheral device, scanner, computer, monitor, whatever, might nowadays has something like this, like USB connector that you could plug in straight into the system. What most people aren't aware of is they're actually color-coded to describe not only what version of USB they are, but also how much data they could handle. So the first version of USB is called USB 1.1, and the color is white. And when you see the color white, you know that it can handle 1.5 megabytes to, let's say, 12 megabytes of data. Now, the second version, USB 2.0, is another USB-A connector. But this one, it can handle up to 480 megabytes of data. So the next USB version was USB 3.0, and that could handle about 5 gigabytes of data, which is a huge improvement from the previous generations. The only problem is the first version of the 3.0 was not compatible with certain OSs, and what they did is they basically updated that same version to 3.1 Gen 1, where it could handle that 5 gigabytes, and it didn't have any connectivity issues. So it was kind of like a bug fix. This is actually called USB 3.1 Gen 2, and this actually improved the throughput of this connector from 5 gigabytes from the previous generation all the way up to 10 gigabytes, which is, again, a huge improvement. Now, this USB connector, unlike the other ones, it's not typically to pass information from, one device to another. This one is just strictly for charging, right? So whenever you see a red, a yellow, and a green, a red, yellow, or orange color on a USB port, or you know that it's a charging port, right? And even if the system is off, you could technically still charge your device. It'll allow you to do that. Understanding that every USB-A connector has a different kind of throughput, right? How much data it can handle. Let's take a look on what's going on the inside of. So taking a look on the inside of the computer now, where you plug it into the motherboard or your own computer, right? So normally, if you take a look on the outside on your I/O shield or in the front of your computer, you're gonna see a USB slots, right? And in this diagram, they're all blue, so that means they're all 3.1, and they do that to kind of make it easier, right? They're all backwards compatible. So that means that you could plug in a 2.0 or 1.1 into a 3.1 and they'll still work, right? But you can't plug in a 3.1 into a 2.0 and have it work. You have to make sure it's the correct throughput. Now, if you remember the diagram that I drew for you guys before, I explained that the directions basically come from the computer to the device itself. So whenever you plug in a USB cord, right, connector, In this case, it could be 1.1, 2.0, 3.1. Okay. Once you plug it in, the driver that is associated with the USB, let's say you plugged in 3.1, blue USB cord that was attached to something. It doesn't really matter at this point, but you plugged it in, and now that driver, that 3.1 driver, is going to take over control of that device, right? And it's going to use its root hub to kind of figure out what driver is supposed to be used, and then it's going to send that information back to the device. Now, there are different types of Type A connectors, the connectors that actually go into the computer. There are mini connectors and there's micro connectors, and you could see them under the A side or the A column, right? Now the B side, those are the things that actually plug into your devices, right? Your monitors, your keyboards, your mouses. Some mouses, some of those devices, they actually come soldered in, and you don't really have to worry about connecting them. But if they were not soldered in, you'd usually need some type of B connector in order to connect them. Now you could also tell that not all USBs look the same. And the reason for that is as devices got smaller, they needed to change the size of the USB in order to keep up with the changing size of the devices. Unlike the USB Type A connectors that are color-coded, or most of them are, the USB Type B, the stuff that actually plugs into your devices, they're sometimes not color-coded, right? They should be, right? But sometimes it's not necessary because the USB it's for like such a unique purpose or device that there's only really one way you could kind of use this USB. Now, there are times where, like, let's say you're plugging in a USB and you're like, oh man, what side is it on? And you're flipping it around and you don't exactly know like what side is good. Because of that issue, they came up with a USB Type C, which actually has the same connector on both sides. So you don't have to worry about which side is Type A or which side is Type B. You kind of just plug and play. And not only that, but the Type C also has a higher throughput, improving the USB technology. Now here's just another diagram just to show you guys the difference in all the versions of USB and their throughput and how it's increased over time. Here's some more examples of Type A versus Type B plugins, and take a second and see if you can identify which one is which. So over time, with the decrease in size of the technology we're using, you're seeing a advancement of USB drivers, right? And you see different shapes, sizes, colors associated with the change in technology. Now, most computers nowadays have a bunch of stuff that plugs into them, and most people don't have to worry about like what happens, right? They plug it in and it just starts working. But exactly how do they work? Now, if you guys remember this example, you remember that each USB port is kind of connected to a drive. And a drive is basically like software that is installed on your actual motherboard, right? In this case, this probably would be on your Southbridge chip on your motherboard. All the drivers for the USB would be on the Southbridge. And if you guys are interested to know what that is, take a look at some of my other videos. And what happens is, because there are so many devices nowadays, the OS systems actually have drivers like built in already. Like Microsoft has a whole suite of different device drivers that, like, if you buy a device and you plug it in, it just works because it's a common device being plugged in. Other devices drivers you might have to download. All right, guys, I think I've touched upon kind of the overall gist of USBs. I hope you guys learned something. Leave me a like and a comment if you guys want to learn more or you like the content. And I'll see you guys in the next one.